preparing. Okay, we're starting. All right, this is the final review. We're on chapter 7. We're on polynomials. So starting with just adding and subtracting polynomials. Just like as a refresher, what is a polynomial? It is an expression with terms where we have powers, and the highest power is called the degree, right? Remember this? And the number in front is called the leading coefficient. You remember this? And then the term without a variable is called the what? It's called the constant term. Okay? Does this ring a bell?
Hold on.
So we have leading coefficient, the degree is the highest exponent, and then the constant term is all that. We got notes? You got notes? For future reference. So in case you want to watch it back. I have like one extra notes packet if anyone needs one. One extra. Okay. So to combine like term, like what needs to be true? Yeah, I have one here. To combine like terms, what has to be true? They have to have the same, not denominators, the same, not leading coefficient, but the same variables, right? Same variables, and then they have to have the same powers. So, for example, like if you have 3x plus 5x, that's 8x, right? We can combine them because they have the same variables, but I cannot add 3y plus 3x, right? I cannot combine these two. Make sense? Same powers means, right, 3x squared plus 4x squared, that's 7x squared.
Do we have a second to copy everything down?
Yeah, I'm not gonna rush. And then we have like, if you have 3x cubed plus x squared, all right, I cannot add these. These stay separate. Does that make sense? Any questions on that? This is familiar, right? Same variables, same powers. If you're done, why don't you try these problems below?
You have to be very long.
Wait. Same variables.
Same variables meaning like 3x and 5x is 8x, but 3y and 3x you cannot combine. 3x squared plus 4x squared, same powers we can combine, but different powers we cannot combine.
What chapter is this?
This is chapter 7. So when you got that down, try these problems below. These were a couple tests ago. This is chapter 7 test. You guys did this.
Are we gonna get like a practice final?
Yeah.
Great. How long is it gonna be?
Wait, is the final gonna be like super duper long?
It's 60 minutes, so it's not super.
Like, is
How much
it
pages?
like as big as this?
No, not at all. This is just all the notes you need to know.
So will we have like a page on, like less than a page on each thing? There will probably just be a couple notes.
Yeah, exactly. It's not going to be crazy long. There'll be some multiple choice.
Oh, thank God. Thank God!
Yeah.
But that doesn't really do for math. You still have to check all those stuff.
I know, but if your number is close to any of the numbers in the multiple choice, you just pick the number that's closest to your answer.
Okay.
Or you just...
All right. How are we doing on these guys? Okay.
Oh, sorry, yeah.
Have we tried? Why don't we try these as a review? So again, one mistake I saw in that test was sometimes students multiplied these, but we're not multiplying, guys. We're just adding here. We're adding here. We're subtracting here. You are not multiplying, right? You are adding or subtracting. You would only multiply if it was back to back parentheses. That's multiplication. But we have a plus in the middle, you add. When you have a subtraction in the middle, you subtract. We done it?
Wait, are we only practicing the first two?
Do these 4. Try these 4. Yeah. I'll give you a minute.
Don't you have to, like, kind of distribute the negative?
You do.
Be careful.
That's why it says be careful.
Be careful. Do you just distribute the like negative?
Yeah.
Oh, oops.
Oh,
That is not what I did.
that did not happen.
So we get a lot more.
Wait, on the negative? Yeah. Okay.
Wow,
Wait, we want the standard form, right?
Yeah.
Oh.
It's negative 7. It's negative 7. It's negative 7. Negative 7. That's not what I was just jamming.
Okay, wait,
It's not like I'm being lazy. Like,
pause.
We just mash these up and add her.
Yeah.
Negative 7.
Be x squared.
8. Oh my god.
3x
Minus 7.
and minus 5x.
All right, here we go. I'm moving on.
Wait.
Wait, can you like 2 more in?
All right, 2 minutes.
What?
Minus 3. That's like the technical.
All right, first one.
The technical.
What do we get? First one. Hello? What do we get?
Hello.
3x squared minus 7x plus 1.
Perfect. We agree with that? Okay, second one. What do we get?
4m cubed
4m cubed
plus 3m squared
plus 3m squared
plus 5m.
plus 5m minus 1. Good. Do we agree with that?
Nope.
No?
Yep.
Okay. So again, you're only combining terms of the same exponents here. When we subtract, guys, you have to distribute this negative to each term inside this parentheses. So it's going to be 2x squared minus 3x plus 4, but then minus x squared plus 4x plus 3.
Can you move it up a little bit?
Up?
Yeah, like that.
Do you follow me on that? So each of these terms we applied a negative sign to. Now we combine. 2x squared minus x squared is x squared. Negative 3x and 4x is x. And 4 and 3 is 7. X squared plus x plus 7. Did we get that?
Yes.
Okay, last one. We distribute 7m cubed minus 3m squared plus m minus 4 minus 4m cubed plus 5m, minus 5m squared plus 3. What do we get when we...
Wait, that's a lot.
Well, all I did was distribute that negative.
3m cubed minus 8m squared plus m minus 1.
3m cubed
Minus 8m squared. Yeah,
minus 8m squared. Yep, sorry. Minus 8m
plus m minus 1.
plus m minus 1. Good. Perfect.
Wait, I have a question.
Yeah.
Because right, you're distributing the negatives, right?
Yes.
So it's minus 7m to the third, minus 3m squared, plus m. And then the other side is minus 4.
The other side, you distribute this negative to every
Yeah,
term.
I'm aware of that. But like, should we separate it like they're 2 different problems? Or, no, you like add them
Plus 1.
together. Okay.
Yeah, you just combine them.
Plus 3. Huh? Negative 4 plus 3.
Are we good on this page, guys?
Yes.
Okay, I'm turning the page. All right, we're on multiplying polynomials. Okay, how do we do that? Do you remember?
Approximate. No.
What does this equal? Can I get a volunteer? Addie, potentially?
Wait, I don't know.
Okay,
Wait, is it 3m squared
yeah,
minus 15?
there you go. Minus 15 what? M. Yeah, we just are distributing this term into the terms inside the parentheses. When we do it area style, that means you draw the box, and on one side you have one of the terms, and then on the other side you have your other terms you're multiplying, and then you multiply in the middle. So 3m times m is 3m squared. 3m times negative 5 is negative 15m. That's it. 3m squared minus 15m. Are we doing okay so far? This familiar?
Okay, yeah.
I don't remember seeing that ever.
Yeah, I don't know.
Well, no, I think it's like the box method, but it's like half because
Yeah.
it's not too like factored out.
But we've never done. Have we done this?
Well, no, but it's like
We
a
just
simpler
didn't do
version
that here.
of the
It's
box.
like foiling it out, basically. I hate foil.
Okay.
No, it's okay. It's just like foil.
Wait, on the side.
I don't know area style. But regular
I don't care which method you do. So guys, for when you have, these are 2 binomials, like each of them have 2 terms. What is this going to be? How do we do this? Foil, we'll do foil and then we'll do box. Foil, what do we do?
Objects by everything.
X times 2x is
2x squared.
2x squared.
And then you do x times negative 3.
X times negative 3 is negative 3x,
And then you do 4 times 2x.
is 8x. And then 4 times negative 3 is minus 12. So we have 2x squared plus 5x minus 12. Okay? When we do box method, you draw your box, and then on the top we put, what are we going to put? X and 4 doesn't really matter, x plus 4. On the side we'll put 2x minus 3, and the inside here we multiply. 2x times x is 2x squared, 2x times 4 is 8x, negative 3x, and negative 12. Again, we just combine, same idea, 2x squared plus 5x minus 12. Right? We add those two together to get 5x.
Can you go a little slower?
Yeah. I'm gonna leave that there for a moment while you copy it down.
Should we try the other one?
Yeah, if you're done with those two, why don't you try the difference of squares below?
Is that any different?
It's pretty much the same. There's just like a special pattern that happens with these problems, and you'll see what happens. So once you
Any different?
no, you do it the same way. Are we good with those two? Okay, I'm gonna leave it. Yeah, no problem.
Oh, is it like there's no solution there?
No.
It's not no solutions.
They just cancel each
Wait,
other.
what's
They
the
just
thing
cancel
on, for the second one? What are the things on the top?
X and 4, 2x to minus 3. 2x squared, 8x minus 3x minus 12.
No, I mean like on the top of the one.
X and 4.
Is that like a plus?
X plus 4, yeah. Can I scroll
Bless you.
a little bit? How are we on these bottom two?
I'm done.
We're done?
I think.
So this is called a difference of perfect squares, meaning you're multiplying binomials with the same like numerical values, but they have opposite b's. Like notice how like both of these are x and 4, but one of them is plus 4 and one of them is minus 4, and that creates this special outcome, a squared minus b squared. So here, without even foiling it, I know it's going to be x what? It's going to be x
Squared.
squared minus 16. Like I can see that because it follows this
I
pattern.
can't see because of your big podium thing.
But couldn't we still for it?
How's that?
That's good.
You can still, yes, sorry, you can still foil, and we would get x squared minus 4x plus 4x minus 16, and then these two would cancel, and you'd get the same thing. Okay? Yeah.
Can I get your banana view?
I'm not done yet. I'm still working on it.
When you're done, I'll get that.
Why do you want it?
No reason.
Please don't give it there.
I feel like I don't want to give it to you.
Why?
I don't know.
Give it to me.
I feel like you're going to cause mischief with it. All right. The next one, 4x squared minus 1, yes?
That word in particular. Wait, I need to take one.
Do we have a second and
Sorry?
I'm gonna make you look like a cartoon.
I'm going to leave it up for a minute.
Put it down so where you walk and you sleep. You can eat it.
I thought you were going to see me dropping it backwards.
I wouldn't do that to you. You're gonna get hurt. You're gonna take fall damage. This is so high. Why do you always do this, bro? I'm trying to massage your shoulder.
Yes, and check.
Hey Eli, did you hear Edson shout out to you in the video?
What video?
Again, you're supposed to watch the video from last class. You gotta check your email. You gotta look at my emails.
Oh, I just don't know.
And in that, Edson shouts you out.
we also probably
No,
die in the
I shouted you
potato
out.
famine, guys. It's okay.
You went through that class.
Alright.
Oh, wait,
I can't do it again.
wait, is that the heart rate thing, or is it like the heart moves your arms or something?
No.
All right.
Just me? Okay.
Factoring, guys, factoring. When it's x squared, bx, and c, when the a is 1, what method do you guys like to do here?
Ace. Factor.
The diamond method, right? So what number goes on top?
we skipping the first one?
They're all the same problem. Negative 10 goes on top. So what two numbers multiply negative 10 add to get negative 3?
Negative 5 and 2.
And that's it. Your factors are just x minus 5 and x plus 2. I mean, I think, is this the way everybody, does anybody do it a different way?
Do you set it equal to 0?
I don't do it a different way.
You don't set it equal to 0 or what?
So this is just factoring. You don't, there's no, we're not solving.
Okay.
Okay, are we good on that one? Box method is just like when you fill in the box and then you're guessing checking, kind of.
That's really dumb.
I don't like that one.
Yeah. I think we like diamond method here. Okay. All right. How about when it's ax squared plus bx plus c? So this is when
I still like
we have a number, right? A is greater than 1.
I still like diamond.
Or A is not 1. We still like diamond. Okay, so
Wait, the diamond method is easy, right?
so the diamond method is a little bit different. When this is not 1, it's the same start kind of. You draw that diamond. What goes on top?
To multiply a
Negative 6.
Yes. So what goes on top? Negative 6, because it's AC. 2 times negative 3. On bottom would be,
negative 5.
what two numbers multiply negative 6 add to get negative 5? You had it. No, close.
Negative 3 and 2.
So that's
Negative. Wait, no.
negative,
Negative
it's not 2 and 3. It's negative
6 and 1.
negative 6 and 1. Okay? So are those your factors, negative 6 and 1?
No.
No.
You have to do more.
That is such a common mistake. Okay?
100% failed loss.
What do we do here? We split this into
That.
2x squared minus 6x plus x minus 3, right? Then we take out the greatest common factor of each side. So we're going to take out 2x from the left.
Whoa, hold on.
Wait, this is like really not it.
Wait.
We did this, but I like don't.
Wait,
I don't think I
4x?
personally did it.
Wait, yes, you did. We had a test on it.
Oh,
Wait,
really?
Mr.
Okay.
Kelly,
Yeah.
this is 1x, not 4x. Oh, sorry, there's a plus sign, sorry.
Yeah, no, you're good. All right. So then we would get
Wait, what did you take out from the right side?
there's nothing we can take out from the right side, so it's kind of like an imaginary 1 right here. So what are our factors?
Wait, what does the last thing say? It's x 2x
2 and
and then
2x plus
x
1.
minus 3 and then
Plus
8
1 x minus 3.
plus 1 x minus 3.
What are my factors?
2x plus 1.
2x plus 1
Yeah,
and then x minus 3.
exactly.
Are there supposed to be parentheses on the another parentheses around the plus 1 x minus 3?
Everything's written correctly, so I don't know what your question is exactly, but
You control it? No.
box method.
Can I leave it alone for like 3 years?
You're confused.
Yeah.
So box method is when you
Can we like this method is
Yeah.
confusing.
okay. So for diamond, Liza, for
Do we
diamond.
have to know this method?
Yes.
Like,
For diamond method, when A is larger than, when A is not 1. Girls.
Wait, why is it minus 6 as well?
So the minus 6 comes from AC. 2 times negative 3 is negative 6.
Why would it not be minus 3?
Because the A is not 1. That's why. If the A was 1, that would be the case.
But do we have to do in this method?
No, I mean you can do the other method, and I'll go over that in a second.
But will we have to like do each method?
No, I don't care about the method, but you have to be able to factor when A is not 1.
Okay, but technically we could just box it.
You could box it and guess and check it.
Okay.
Are we okay on this method? AC, B, 2 numbers, split it, factor, that's it. Okay? If you do box method, you fill in 2x squared and minus 3, and okay, this has to be x and this has to be 2x, and then you play with the numbers so that these 2 numbers add up to negative 5, right? So then I could test, oh, this is minus 3, this is 1, this is minus 6x, this is x, these 2 add up to negative 5x, so these must be my factors, x minus 3. You don't have to do that. Okay, that's the way I learned it in high school, but this is, I think, a more straightforward way. Okay? Are we good on factoring?
Wait. I wrote them in on spot.
What? Put all the perfect squares.
Oh, stop it, man. What's guess and check? You actually guess and check.
Yeah, we're not doing guess and check. Can I turn the page now? Okay, I'm turning the page. All right, we did a chapter. We're now on chapter 8. Okay. Let's graph. Graphing y equals ax squared. What does a tell us?
Tell us.
Not the slope. Ax squared. It's not the slope. A tells you two things.
The x intercept. I don't know.
If a is positive,
Oh, it tells you if it's going up or down.
it goes up. If a is negative, it goes down. And a tells vertical stretch. It's called vertical stretch. Okay. Is this going up or down, this one? It's going up or down? It's going up or down. 1/2 x squared. Up or down?
Up.
Up. Okay. Where do we start? What's a good thing to do when you're trying to graph a function? You want to make a table, right? With x and y. What's a good number to try? What's a good number to try?
1.5. -2. 0.
0 is good, right? What's 0 going to be? 0 is going to be 0. That's easy right here. What's another good one to
You
try?
know that?
1.
1, sure. 1 goes in. What's 1 squared? 1 squared is
1.
so 1, and then divide by 2. It's going to be 1/2, right? And we know that parabolas are what? They are. There's not rise over run. That's linear equations. Parabolas are symmetrical. So that means if this is a point, this also has to be a point, right? And then one more, 2. 2 squared is.
Wait,
Then divide by 2.
2 is 2.
2. There we go. So we
I'm
have.
so confused.
wait, yeah.
It's not fun.
You just plug in something and then you just
Yeah.
do the equation and then you graph it and then you
Exactly.
just
Wait,
mirror it.
so is the one on the right, like, is that at, like,
Wait, the
1-1?
Which one? Here?
No, like the 2 points that are symmetrical, or is that at 1-1?
Right here?
Yeah.
1 1/2. 1 1/2.
So it goes to the side 1 up 1, right?
It goes 1 to the right and then up a half.
So it's only up a half. That's kind of weird.
Yeah, because we have this half here. Okay, let's.
Wait.
Yeah.
Wait. I'm so confused.
You're confused? Dude, all we're doing is plugging. So you're choosing nice x values and plugging them into this. What's 0 squared?
0.
What's 0 times a half?
0.
So 0, 0 is a point.
See, yeah.
Now 1 goes in. 1 squared, 1. Times a half, 1/2. That's a point.
1 times a half.
Yeah. 2 squared, 4. 4 times a half is 2. That's another point. And then because it's symmetrical, we can just go across. Okay. Next one. -2x squared. Is it going up or down? Hey, girls. Is it going up or down?
Down.
Down, okay? Let's do the same thing. Plug in some points. What's a good point to start with?
0.
0. 0. What's 0 squared?
0.
What's 0 times -2? It's just 0, right? Okay, so 0, 0. How about 1? 1 squared is?
1.
What's 1 times -2? -2. So 1, -2 is a point. And because it's symmetrical, this also must be a point. Let's do one more. 2. What's 2 squared?
4.
What's 4 times -2?
-8.
-8. So it's actually going off the charts. It's kind of down here.
Do we need to do another?
It's just good practice. Okay? That's it. Are we feeling good about this so far?
Wait, do we have one chapter?
Yes.
Okay. Now ax squared plus c. If we have ax squared plus c, it's very similar, but what does the c tell you? C is the what intercept? It's the y intercept. Good. So right here, does yours have the same printing error as this? Does yours look the same as mine?
no, we have a graph.
Oh, good. Okay.
Wait, I can't. Oh, wait, it's there. You just can't see it.
I got to turn the page over. What's the first one? Y equals.
1/2 x squared plus 2.
Okay. And the second one is y equals.
-2 x squared minus 3.
Okay. So how would we go about graphing these?
Wait, what the hell is
Plug
oh,
in.
it's 1.
Plug in stuff, right? Make a table.
Wait,
What's your y-intercept though?
2.
Y-intercept is 2 right here. What's the y-intercept here? -3. Okay. And then if you were like kind of stuck on what to do next, you can just make a table, guys, right? We plugged in the 0, we got the 2. Let's plug in a 1, right? 1 squared times a half, that's 1/2. We're going to get 2.5. Do you follow me on that? No, it's not.
You're a scary number.
Oh wow.
Okay. And on the right side, same thing.
Wait,
Hey, guys.
wait, I don't get 0, 1. You did not plot that.
Wait. Yes, you did.
So 0 is 0, 2 is 1 point.
Okay,
Then
so I can't count.
1 is 2.5. You're good. Okay. On the right side, we have 0, -3. When I plug in a 1, I'm going to get -5. So we'll have this sketch. Okay? Are we feeling okay?
So fast.
When in doubt, make a table. When in doubt, make a table. Okay?
Wait, hold on. Did I do that for 6:30?
Are we good? We grabbed it?
Yes.
Grabbed it?
No.
Do it.
I'm going to college.
Sure.
They're
I
calling
know.
me for college athlete.
I know. Do the graphic.
I got a D.5 on
A what?
nothing.
Okay.
I did have pneumonia and I was unable to
College.
come into school for like
Because you
2 days.
don't email.
What you mean? About
It's 'cause it's not- it's
our
not-
potential, bro. That's more than 0 in college. College.
You have to show.
College reached out to you?
Huh?
A college reached out to you?
Maybe.
That's cool.
Maybe so.
During the school day.
All right.
Parents email.
Last one.
Wait, well, can you go back to that other one, please?
Wait, relax. You need some fruit, Mr. Kelly.
I know. I don't know what's wrong with me.
Wait, can I see what your graph looks like?
Where do you live?
Ready.
Can I scroll down now,
Yeah.
please? Okay. All right. Graphing ax squared plus bx plus c. How do we do this? So, things to do. How do you find the x-intercepts? How do you find the x-intercepts? You set it equal to 0 and factor, right? So the x-intercepts for this first one, we would get, I'm going to do the first one, and then you need to do the second one by yourself, okay? So the first one, we have x squared minus 4x plus 3 equals 0. Let's factor. Two numbers that multiply to get 3, add to get -4. What are they?
Wait, what?
Two numbers that multiply to get 3, add to get -4.
Multiply to get 3.
Wait,
Negative 3, negative 1.
-3 and -1.
There we go. So that means that my zeros are at what point? What are my x-intercepts going to be?
Don't you have to solve it? So
Yes.
X
3 and 1.
3.
X equals 3 and x equals 1. Those are my x-intercepts. So I can go ahead and plot them down here. 1 and 3. Those would be your x-intercepts.
Wait.
No.
Why do they not become? Oh, do you set?
Because you set them each equal to 0. So x minus 3 equals 0. And then x minus 1 equals 0. And then they equal 3 and 1. How do you get the y-intercept, guys?
Just go straight in the middle.
No, but like,
Oh, not the line.
what do you plug in to get 0? To get y-intercept, rather. You plug in.
It makes it like the x-intercept equals to 0.
No,
So No.
2A.
to get the y-intercept anytime, you just plug in a 0 because it's when x is 0 that you have the y-intercept.
That's what I said.
I couldn't understand you. So
Oh,
what? I couldn't.
How do you know it's negative 3? It's
Sorry,
negative
positive 3.
Yeah.
Wait, also, is it just you're plugging 0 in for X?
Yeah, you're just plugging in 0 for x. So we got our y-intercept, we got our x-intercepts. How do you find the vertex, guys? Do you remember this?
Wait, how does that? Oh, I see. No, I don't see at all.
No, I don't see
Because
it.
Oh, I
it's
do
gonna be
see.
like lower. Like the vertex is gonna be like the margin.
How do you find the vertex?
Negative b over 2a.
Negative b over 2a, right? Comma
Comma
f of negative b over 2a. So what's negative b over 2a?
4 over
4 over 2. So it's just 2. Then plug it in. What happens when we plug in a 2? We get 4 minus 8 plus 3. What's 4 minus 8 plus 3? Negative 1. Okay? Then this all comes together, and we can sketch. Okay. I'm going to go over that one more. I'm going to go over that one more time. I'm going to pause the video. There we go.
Wait, I don't understand why my negative b over 2a is a decimal.
Okay.
What's
It's
your
okay.
decimal?
All right. So, x-intercepts. How do you get your x-intercepts?
You set it to 0 and you factor.
Set it to 0 and factor. Here we go. X squared plus 3x minus 4 equals 0. So, two numbers that multiply to negative 4 add to 3 are negative 1 and 4. X minus 1 and 4. So that means that your solutions are, it's a plus here. Sorry, that's not clear. Your solutions are x equals 1 and x equals negative 4. So I can plot them 1 and negative 4. Okay? How about the y-intercept? Plug in 0. So what's our y-intercept? Y is just negative 4. So right here. Okay? Then vertex, right? It's negative b over 2a, comma f of negative b over 2a.
Wait, y equals what?
Negative 4, right? You plug in a 0, you get negative 4. So negative b over 2a would be negative 1.5. Negative 1.5. And then using the calculator, what is the 2 point?
What?
That's just not right, guys. I think it's negative 6. I was guessing.
Let's use a calculator, guys. So it's going to be negative 1.5 times negative 1.5.
Maybe 5.5.
So we're going to have 1.5 times 1.5. That's 2.25. And then it's going to be minus 3 times 1.5. That is...
6, right?
No, 3.
That's 2.
3 times 1.5 is 4.5. So it's minus 4.5. Then it's minus 4 again. So we're going to get negative 6.25. So it's right down here.
Wait, so it would be minus 4 minus 6.25?
Can we not get a problem like that?
Yeah, please.
Yeah, I don't like this.
Wait, Mr. Kelly, what's the answer? Is it minus 4 minus 6.25? Well, I don't even know.
Oh, wait, I kind of understand it.
That's not relatable at all.
So when we plug in negative 1.5, we're going to get negative 1.5 squared plus 3 times negative 1.5 minus 4. And that comes out to negative 6.25. That's that right there.
Wait, so it's minus 6.25?
Yes, that's the y value.
And then what's the x
I
value?
really didn't.
The x value is negative 1.5.
Wait, how much it really is so
Wait, it's not from negative b over 2a. Wait, what?
Yes, that's negative b over 2a is negative 1.5. Then we plug that into the equation and we get negative 6.25. That's what that is there. Yeah. We're so close, guys. We're getting there. Can I turn the page?
Yes.
Yeah? Okay. All right.
Graphing in vertex form?
Vertex form, yeah. So this is actually a little bit easier. When we graph in vertex form, it's nice because what does it give us very clearly? It gives us the vertex. What are the coordinates of the vertex from this form? It's what? H comma k. So what would my vertex be here?
Wait, what?
Careful. So h is negative in our form. So it's not 2 comma negative
Yo,
4.
Wait.
Okay?
What?
Wait,
Just let him do it on here. We can watch the video back or something. It's fun. Just try to pay attention on here. No.
Is the one
Because now the video's been going for what, 30 minutes?
The 1/2 doesn't affect the vertex. Then once you have the vertex, you can just plug in a number next to the vertex.
Wait, 2
Like-
and then -4.
2, -4 is the vertex. So,
What's K?
so let's plug in a 1. 1 is the y coordinate of the vertex. If we plug a 1 in to the equation now, we'll get 1/2 minus 4. We'll get -3.5.
Mr. Kelly, you have such ugly numbers in your problem.
Yo,
Bro, they're all the numbers.
Wait, I'm pretty sure he did not write this packet.
you want me to get on Mr. Kelly?
That's what we got. All right.
What on earth?
Rather not credit.
Next one. What's the vertex of
I'm
this?
sorry, where did you get the points for the first one?
Sorry, ask your question again.
I just don't get where you got the points.
Where I got the point from?
Well, I got the one that's less 1 and -1. Where's the other 2 points?
So my main point HK comes from 2, -4. That's your vertex.
Oh.
Right, so that's my main point. And then I just plugged in a 1 because it's by 2. And then I got -3.5, and that got me these other 2 points right here and here because it's symmetrical. So it got me 1. Like 1 is -3.5, and 3 would be -3.5.
So you got 2 -4, and then -1 minus 3.5.
Yeah,
And then the other one
is 3 -3.5 because they have to be symmetrical. Right, this is a 3 here.
Aren't they both? And the other one is 3 minus 3.5.
Yeah, because it's symmetrical.
I'm so lost.
What's the vertex here? What's the vertex here? H comma K. -1 and 3. Do you see where we got that from?
How?
Wait, how did it
The 1
How's
is
it negative?
the 1 is here. The H is the opposite of whatever's in here, and the K is the number out here. So it's -1, 3. So let's go ahead and plot that. -1, 3. So when I make my table, what's a number that's close to -1? What's a number that's 0? So let's plug in a 0. We plug a 0 in here. What are we going to get? We're going to get -2 plus 3. We're going to get 1. So 0, 1
Wait, what? How'd you? Oh.
is a point. And if 0, 1 is a point, then -2, 1 must also be a point because it's symmetrical, right?
Wait,
This,
Mr. Kelly.
yeah.
Do we not wait? Over. Actually,
Oh, never mind. Wait, no. Would it not be -1 and -3?
No, it'd be -1, +3 because the K stays the same, but the H is the opposite of whatever's in there.
Is it enough just to do like 3 points? Yeah.
Yes. All right, well, guys, we're so close. We got 20 minutes left. We're on our last chapter, the most recent chapter. Let's go through some perfect squares.
Whoa. Wait, can you zoom in? Can you zoom in? It's literally just
It's 1 through 12 squared. Can we fill this in? 1 squared is,
1,
2 squared is,
4,
3 squared is,
9,
4 squared is,
16,
5 squared is,
25,
I'm not this fast.
6 squared is.
36.
Wait, you're going fast.
Okay, I'm going to pause.
Why?
Wait, is it?
There, they can see the answer when you. It's fine. They can
Yeah,
write it
just
down.
just leave it there for a little bit after.
Keep going, Kelly.
Come on, I'm on a streak.
7 squared,
49,
8 squared,
64,
9 squared,
81,
10 squared,
100,
11 squared,
121,
and 12 squared.
144.
Cool.
Hooray!
All right, let's do some square roots.
Wait, no, now leave it because I didn't write it.
Okay.
I'm not writing it.
Why do you need this many? Like, in what world?
It's good to know the perfect squares. It's helpful.
Oh, these are the perfect squares?
Yeah.
Write it on your test cards, guys.
You also get access to a 4-function calculator, so
I don't know how those work. Anyway, it doesn't matter.
you don't know how they work? Buddy, what do you mean you don't know how they work?
Is that the big one? That one?
No, these little guys.
Oh, I know how that one works.
Okay.
Mr. Kelly, I do not know how to use this. Why can't I just use it? Like, I don't know how to. I legit. I've tried. I don't know
anything on it.
Yeah,
I like legitimately don't know how to use any of these buttons. I don't know how to use the square root and the
something I
square
would
button.
like possibly use.
the square root and the square button.
Okay.
Parentheses.
All right, let's do some variables. So, how about square root of x squared is what? Square root of x squared is just x, right?
Wait, what's 12 squared?
144. Square root of x to the fourth would be what?
X squared.
X squared. Square root of x to the eighth would be
X to the fourth.
x to the fourth, right? Not something different, right? Square root of x to the 16th would be
Isn't
X
the
to the
first
eighth.
one also supposed to be square
x to the
root?
8th. Sorry?
Why isn't the first one a square root?
So when we square root a variable with an exponent, what do we do to that exponent? We
Divide by 2.
divide it by 2. If I had something like the square root of x to the 9th, how would I do that?
You break that.
You break it down into what? Two parts, right? X to the
X to the
X to the 8
And-
X to the 1.
and just x. So what's root x to the 8th times root x? What's root x to the 8th? That's just
X to the 4.
x to the 4th root x. Okay?
Wait, is the first one a root?
These are all roots here.
Wait, but
Oh
the
my
first one's also a
X
root?
to the fourth.
Root x squared is x. Root x to the 4th is x squared. Root x to the 8th, x to the 4th, root x to the 16th, x to the 8th. We just divide it by 2. If you have an odd exponent, you take out the biggest even exponent and then
What
separate.
if it is even?
Then you just divide by 2.
Oh, you're right.
What about something like root 64 x to the 4th?
We were still going.
Alright, so you root the 64.
Yeah. And you root the x to the 4th. What is this?
That a 8 root
Wait, can you take
X
your hand off so we can see it?
8 root 2. No, 8 2. Where the root 8x2 root.
There's no root. Because it's an even language. Because it's an even number, you just divide by 2.
Is there a reason you skipped the row?
No.
So
I'm
why
just,
you just try to pick me up like that?
yeah.
What's wrong with that row? What does that row do differently that all other rows don't do?
I just wanted to cover enough examples. We're good on this
You
table.
have to do the last one.
We're good on this table. We're gonna turn the page over. Can I turn the page over? I'm turning it over. We're so close, guys. We're 2 pages left.
Wait, what about simplifying radicals?
Yeah, that's what I'm on. Simplifying
Oh, you
radicals.
have to flip. We don't.
I have to flip.
Kind of loser.
Why should I pick different?
All right.
I said
Root 20x to the 7th. What would this be, guys? How do you do it?
break it up.
Break it up. What are you breaking the 20 up into? The biggest.
4 and 5.
Yeah, 4 and 5. Because that 4 is a what? 4 is a 4 is the root square. And then x to the 7th we break up into what? And x. Good. So let's simplify this. Root 4 is
2.
root 5 I can't do anything with.
So 2
Root
root 5 and
X to the,
x to the third.
and then
X. Root x.
root x. That's it. Done. How do you simplify this one here? 2 over
Multiplied by root 3 both sides.
root 3 over.
Root 3.
So what do we get? 2 on the top we get.
Wait, shouldn't it
Two
be
root
2x
three.
to could it be 2x to the
At the bottom
third?
is 3.
Like for the other one, could it be 2x to the third, x squared 5 and squared x?
Do you mean square root? Like
Yeah, that's what I mean.
I'm okay if you put it in a different order to me. It's okay. But in general, you want the numbers first and the variables second. Okay, how about last one here? Root 100 over x to the 16th? What's that? 10 over x to the 4th. Okay? All right.
Do you not just go, why is it X?
Wait, no, it's 8.
Yeah, it's X to 8. Wait.
X to the 8th. Oh my goodness. That was an air ball. Okay.
Bro.
Get out. Wait, 10 adds what?
Maybe not, but
Wait, Mr. Kelly, it's okay, Mr. Kelly.
I feel like the meaning of airball changed in my time at Priory. Originally, I thought it meant like you just messed up, but then it developed to mean like when you like ask a question, nobody responds. Yeah,
Wait, is the answer
But
no,
do you know
like,
why it is like that?
square root of 3?
yeah, because it's like you missed entirely airball. Yeah.
Yes. Missed the rim. Shot. Your attempt missed. Yes.
Okay.
Like if a joke doesn't land, airball.
Yeah.
If someone lands, it's a break. Yeah. But airball.
All right. Let's do these quickly. Root 32.
16 and 2.
Run, you mean? Ran over.
Sorry?
What? Am I right?
Yep.
Wait, whoa.
Hey guys, we're going.
No.
The train is leaving.
16 and 2 again.
That's present tense instead of just present subjunctive. Okay.
Yeah.
Can you like circle the final answer?
Yeah.
Mr. Kelly, I feel like you kind of need to verbalize.
Oh shoot, you want me to go?
I told you the train was leaving the station.
Yeah, and it left without it.
I wasn't even looking. I missed it.
That's without us.
Wait, that last one.
Yeah.
What did you break it up to? 4 and what?
4 and 3.
Oh, 4 and 3.
Glad I didn't feel like me down.
Got it?
No,
No, not even.
I got it, Mr. Kelly. You can continue.
Mariana, shut up.
I actually did it, and I actually understood it.
Good job.
Same.
Is that a negative 18 on top?
We're on our last section, guys. Last section.
1,255?
Wait, actually.
What's the bottom left say?
-2 square root 5.
Bro, that's negative 12 root 5. Bro, that's like negative
Wait, on the top, aren't you
1,255.
supposed to combine those?
No.
Where?
Like
can't
it's a 4x.
Is that a 3? I'm so lost.
It's what, 3?
So, which one are we lost on here?
Wait, no, I just like
The
chemistry
top,
writing.
the top right corner.
This one here?
Aren't you supposed to like combine them?
4 root 2 x squared root x. There's nothing more I can do here.
Well, yeah, well, like, aren't you supposed to put them together so shouldn't it be like 4x squared root 2x?
No. Numbers together, variables together.
Why?
That's just the way we do it.
You can't.
It's okay if you do, like, I'm not going to take your points up for that, but in general, numbers together, variables together.
That's not what I've been doing.
I'm really confused.
Oh, I see what you're saying, Devin.
4x
You could write this as, I see what you're saying. You could write as 4x squared root 2x.
Yeah.
Okay, that's fine with me if you write that like that, but I prefer this notation.
You can combine the roots, so it could be
Yeah.
just one root and inside is 2x.
Yeah.
Ew, no, that's a lot of work.
All right, we're moving on,
Is
guys.
this the last?
Last bit. This is what you know how to do. Solving quadratics for method. So,
We do not in fact know how to do this.
if to solve by graphing, how do you do that?
Oh, I know how to do this actually.
Oh, is it the ABC thing?
Hey, eyes up. We got 10 minutes left. We're so close to the end. Please. To solve by graphing, what do? You look at the graph. What are the solutions here? They are the
and -4.
the x-intercepts, -4 and 1. That's
Wait,
it.
What?
Wait, that's it?
That's it.
Since when?
That's always been the case.
Really?
Yes.
Wait, are you kidding me?
Yeah.
No.
Wait, what?
Wait.
To solve by graphing, right? This you're basically graphing x squared plus 3x minus 4, and then 0 is just this line, right? 0 is just the x-axis. So the solutions are just where they intersect the x-axis. That's it.
So it's -4.
Thank God.
So use when graph is given,
Why
right?
did we even have the equation up there?
Yeah, what's the point of the equation if it's just...
It's just bringing it all together. Okay, to solve by factoring, how do you do that? Let's do it.
You factor.
How do you do it? So before you
Set it to
factor,
0.
set it to 0. We get x squared plus 5x minus 24 equals 0. Then diamond,
Oh.
two numbers that multiply to -4 add to 5 are
Wait, -4.
-24 add to 5. What are they?
I don't know, I'm too hungry for this.
8 and -3. Thank you, Mariana. That would be x plus 8 and x minus 3. So my solutions would be, you set each of those equal to 0, right? X plus 8 equals 0. X minus 3 equals 0. Your
X
so
equals -8 and X equals positive.
x equals -8 and x equals 3.
So unfortunately, that was too fast.
Okay?
Okay.
Good. The last method is complete the square.
Wait,
Whoa,
wait, do
hold
we
on,
have
sorry,
to do
like,
the
I
last
need to
method? What did
Hey. I'm gonna let Mariah finish, and then I'm gonna set up complete the square to the right here. So I'm gonna write it out as.
Do we know how to complete the square?
It's b over 2 squared, or negative b over 2 squared.
Oh, it's there. I'm just.
Oh. Okay.
Wait, what is by square root measure? Is that complete square?
Do we just
Yeah.
distribute the square?
So I'm gonna go back a step from this, so you can.
Angry.
Well, why would you do that? Isn't that already like the way?
Yeah, I'm just modeling it.
Do we add 36?
Okay.
27?
Yeah. So refresh your memory. Complete the square. You get the constant on one side, and then what do you do to both sides here? You add.
You add b over 2.
B over 2 squared both sides. What is b over 2 squared?
That would be negative 9.
Just
Or
9.
positive 9.
Yeah, so x squared minus 6x plus 9 equals 36.
Can you go over it again one more time?
Yeah.
Eli, move.
Can you sit down?
Where'd the break? How did it change?
Huh?
How did it go from this to x squared minus 6?
I made a new problem.
Just going back.
Oh, you made
I made a new problem, yeah.
Can you tell us how to do the actual problem though?
Yeah, I mean, the actual problem is very straightforward. This problem, to complete a square, you add b over 2 squared to both sides with a constant on one side. Once you do that, then you can rewrite this trinomial on the left as a what? You can write this as a perfect square. What's this as a perfect square?
X minus 2.
Not x minus 2, but x minus what? It's b over 2 goes in here. X minus, what's b over 2?
30.
3. X minus 3 squared equals 36.
Wait. Why is it minus 2?
Because it's x plus b over 2 goes on the inside here.
How do you find X?
Okay.
Well, okay, what squared is 36?
How do you find x? Like, how do you solve it from here, this point?
Minus 3 is 6.
So these two are now the same problem. Do you guys see how these are the same problem now?
Square root both sides.
So we square root both sides,
Can we do guess and check?
and we have x minus 3 equals
Plus minus.
6, and x minus 3 equals negative 6. So x equals 9, and x equals negative 3. What do you want to see?
So weird.
Any questions on that one, guys?
Yeah, I'm like really confused.
Complete the square.
It's not that bad. It's not
So
So we have to use that one.
you get be prepared to complete the square.
Why would you make a new equation?
I made use equation because this one was too easy.
Wait, can you like leave it there for a second?
Yeah.
So you
Can we
did
try
x
quadratic
minus
formula?
3 equals 6. Okay,
And we get a note card, right?
Yes.
but if we know how, what if we know how to do this one? Are you gonna do one like that this easy, or do we have to know how to do a really hard one?
You'll get a practice final, and you'll see the kind of questions you're gonna get. That's my answer. Okay. All right. Last one. Let's wrap this up. What is the quadratic formula? First, tell me what it is. It is
X
X
equals
is negative b plus or minus
the
square
square
root
b squared minus 4ac.
all over.
over 2x.
There we go.
Could you move your
You can't
down?
see.
Sorry.
Yeah,
What
you got it right.
to solve using quadratic formula? What do you have to do? You have to
Set it to 0.
set it to 0. So it's 3x squared minus 7x minus 6 equals 0. You relabel a is 3, b is negative 7, c is negative 6, and we just plug in those values.
Wait, wouldn't it be negative 3x squared because you?
No, I left out on the left, and I moved everything over from the right. So
You
I,
want like the thing to be positive.
yeah,
So you have 3x squared minus 7x minus 6 equals 0.
yeah.
If b is negative 7, every time we put a negative b is a 7.
Yes.
So it would be 7 plus or minus the square root of 49 minus 12 times, was 12 times negative 6?
Negative 7.
Wait, 6. Why did you
So-
write 6 equals minus 7?
There's no solution.
Say again.
Plus? Wait, why is it plus?
This is B. This is B, Aisha. B.
Oh, okay, I was really confused.
Okay.
So no solution, it's no solution.
Wait, why
If
is
it-
it negative though? Because A is 3.
What do you mean
Because
negative?
it's
No
negative,
solution.
negative 4 times a, which is negative 12 times another negative 6.
It's an
So
even
it's
amount of negative rows.
Oh, I forget it's AC.
It's not no solution.
Yeah.
You do A times C first.
It doesn't
You
matter.
do 4 times a, and then whatever you get times c. Or that's what I
Negative 18 times.
Negative
Guys,
18.
there is a
It's
solution.
4 times 32.
It's 7 plus minus root 121 over 6. What's root 121? 11. So it's 7 plus minus 11 over 6. So it's going to be 18 over 6, and then it's going to be 7 minus 11, negative 4.
Because 7 plus 11 over 6 and then 7 minus 11 over 6.
Yes.
7 plus minus 11 over 6.
Yes, sir.
And then what from there?
That's it.
What? Wait, what do we have after this?